want to do with functions, the section on functions is to show you how to evaluate functions. And we really have been doing that, but I'll kind of formalize it. I'll use some of the examples in the book here. So let's take the function f of x equals x squared plus 1. And the book asks us to evaluate f of a minus 2 in A, and for B, f of 0. To evaluate this, we simply substitute the minus 2 for x. So f of a minus 2 equals a minus 2 squared plus 1. Well, that equals 4 plus 1, which equals 5. So f, the function evaluated when x is a minus 2, equals 5. Now let's evaluate the function for f of 0. Our function is f of x equals x squared plus 1. So f of 0 means we're going to substitute 0 in for our x. So we're going to have 0 squared plus 1, which equals 1. So f of 0 equals 1 for that function. Obviously, if we had a different function, if we had f of x equals 3x plus 1, and we evaluated this function for f of 0, we'd get 3 times 0. Oh, that's not going to work. Let's do it this way. It will work, but it won't show you what I wanted to show you. That's what happens when I pull things off the top of my head. Let's do this. F of x equals x plus 13. Now we'll do f of 0, and we'll get 0 plus 13. F of 0 equals 13. The point I'm trying to make here we have f of 0 equals 1, and here we have f of 0 equals 13. These are both correct answers. But the important thing to recognize is this relates to a specific function. It related to this function. And this answer relates to this function. And the functions are different, so that when we evaluate the function when x equals 0, we get different numbers because the original function was different. If they were the same, we'd get the same number. All right? Let's do another example from the text. Let's do g of x equals 3x minus x squared. Instead of using an f, they're using a g, and that's common. It's common to use a g instead of an f. But this is still a function. It's telling us that g is a function of x. So g of x equals 3x minus x squared. And they ask us to evaluate this for g of 2, which means we're going to evaluate it when we're going to evaluate this function when x equals 2. So that's going to be 3 times 2 minus 2 squared. So that's 3 times 2 is 6, minus 2 squared is 4. The minus sign is outside of the x. We're not going to square a minus 2, we square the 2. So that's equal to 2. So g of 2 equals 2. And they ask us to evaluate g of 0. Well, that's going to be 3 times 0 minus 0 squared. That's 0 minus 0, which is 0. So g of 0 equals 0. Okay? The last thing that we want to do is talk about the domain of a function. What are all the possible x's for a given function? So the book has two examples here, and we'll look at each of them. We have a function given by the set of ordered pairs -3, 0, comma, -1, 2, 0, 4, 2, 4, and 4, -1. Well, to find the domain of this function, it's very specific. The domain is very specific because we've been given specific ordered pairs. The domain of this function are all of the x values in these ordered pairs. So that would be the set -3, -1, 0, 2, and 4. It's all of the x values for this set of ordered pairs. This is a defined, clearly defined ordered pair, or set of numbers. So number 5 is not part of the domain of this function. 13 is not part of the domain of this function. 0 is part of this domain. Okay? It's clearly defined. Let's look at B. B is the area of a square, is area equals s squared. What would be the domain of this function? We could say A of s equals s squared. What are all the possible values that s could be? Could s be a -1, a negative number? Yes. A -1 squared is 1. But could you have a square that had a negative value for a side? Excuse me. It's not possible to have a side in a square that's negative. So because this is an area and we're talking about the side of a square, s can't have a negative number. Could you have a 0? Well, if this distance was 0, you wouldn't have a square. So s can't be 0. S can't be a negative number. And s can't be 0. So the domain of s can be any positive number. It could be a half, it could be a tenth, it could be a million. The domain of A of s is any number such that s is greater than 0. That would be the domain. Now, if you didn't have this defined as a square and the sides of a square, if this were just an equation, y equals x squared. This is a function, because each value of x generates just one value of y, one unique value of y. So this is a function, and you could have a negative number here. Because this is not defined as a square, the side of a square, the domain of this function is any real number. And we could graph this and use the vertical line test to prove that it's a function and that it extends on the x direction. It would go to infinity both in a negative direction and a positive direction. All right, and that's the end of this section.